Hey there, and welcome to this course on building real-time applications with Momento. So in this course, we'll explore how you can use Momento to build powerful and real-time features into your application without the need to manage your own infrastructure. And all of that complexity of building a scalable WebSocket application that's capable of dealing with millions of users. And you only pay for what you use, not for idle servers that are sitting there and waiting for traffic to come. So what's Momento? It's a serverless caching and a real-time data platform that's designed for speed, scalability, and simplicity. Its caching solution can handle millions of requests per second with sub-millisecond response time. And you can scale your WebSocket application to millions of users using Momento topics. Plus, it's serverless. No need to worry about scaling or maintenance. Just focus on your data, and Momento is going to take care of the rest. So why would you use it over other solutions, like maybe some of the native AWS services like Elastic Cache? Well, it's fast, it's scalable, and the underlying virtual machines are completely abstracted away from you. There's no need to worry about the maintenance windows, updating the engine. There's no need to decide on the number of nodes you want to run, and you never pay for idle, only what you use. And Momento topics support WebSocket out of the box. So whether you are building a chat application, real-time notifications, or live dashboards, Momento makes it really easy to add real-time features into your application with just a few lines of code. And it's scalable and cost-efficient out of the box. Honestly, it's one of the most exciting services I have come across, and I'm a huge fan of the team, which, by the way, they are the team that brought you DynamoDB when they were working at AWS. So they know a thing or two about how to build for massive scale. And in this course, I'll show you step by step how to use both Momento Cache and the topics. And we're going to build 3 different applications to show you what they can do. First, we will start with using Momento Cache to create a fast and scalable leaderboard service that uses a sorted set collection. Next, we will build a notification system using Momento topics to send real-time updates to the front end via WebSocket. You see how easy it is to push updates from the backend to the front end without needing to implement any kind of polling, and how it can be done with just a few lines of code. Finally, we'll create a real-time chat application that demonstrates client-to-client communications through Momento topics. So it will show you how to handle real-time messaging between users. Along the way, I'll show you how to secure your API keys and how to generate disposable tokens for the front end and implement multi-tenancy so users can only subscribe to their own updates. By the end of this course, you will have hands-on experience building each of these applications and a good understanding of how to use Momento's cache and topics to build real-time applications. Okay, so let's get this party started. Momento is a real-time data platform that gives you some nice building blocks for your application, like caching and the topics, which gives you WebSockets that can easily scale to millions of users. I mean, this is a platform that's built by the team that built DynamoDB after all, so they know how to scale things. And since they only charge you for what you actually use, so it can be a very cost-efficient solution for you as well. And they are truly serverless in that you don't have to manage any infrastructure, but also, importantly, it can scale to 0, so you pay nothing when nobody is using your app, which is honestly quite refreshing these days, seeing as so many of AWS services call themselves serverless, like OpenSearch serverless, but they charge you based on uptime. So even if nobody is using your app, you will still end up paying around $200 per month for OpenSearch serverless, which just really goes against what serverless means to us. And this uptime-based pricing doesn't mix well with using ephemeral environments, which is one of the most important practices that have co-evolved with serverless, and it can supercharge your development workflow and make it easier for your team to work on multiple features at the same time. I don't really want to go into it here, but if you want to learn more about why you should use ephemeral environments, then check out this video. Okay, back to Momento. You see, AWS also offers a managed caching service called Elastic Cache, which lets you run Memcached or Redis, and they manage the underlying infrastructure for you. And you can either run a cluster yourself and pay for the nodes by the hour. And sometimes you have to update the engine versions, plan maintenance windows, scale up and down the cluster, and right size the number of nodes, and deal with backup and restore and so on, which does add quite a bit of chore on your plate. That's why they also offer Elasticache serverless, which automates all of those manual work. But as with OpenSearch serverless, you have to pay by uptime. In this case, because the minimum data storage cost is for 1 GB per cache, which works out to be about $90 per month. Again, because of this uptime cost, it's not feasible for me to create a new cache every time I need to bring up a new ephemeral environment to do some feature development. And that's why Memento's on-demand pricing is so appealing, where they only charge you based on the number of cache operations you actually perform, and since it has a generous free tier, you likely won't spend anything for your dev environment, certainly not while you implement the code demos that I'm going to show you in this course. And with this kind of pricing, I'm able to bring up as many caches as I need. There's no uptime cost for them, and I only pay for the actual operations that I do in my app. And besides caching, Momento also have real-time topics, which lets you build real-time applications with WebSockets, and they make it really easy and take away all the technical challenges of building scalable WebSockets. And the best thing is, they also have an on-demand pricing for topics as well, which is again also charged based on the number of operations you actually perform, not for uptime of nodes or the amount of time that your clients are connected to their WebSocket server. And this is in stark contrast to other AWS services that offer WebSockets, such as AppSync, API Gateway, and IoT Core, all of which lets you build WebSocket applications without managing the WebSocket server yourself, which is great, but they all charge you based on the number of messages you deliver, but also how long your client applications are connected to the WebSocket server. So if you have a large number of idle clients that are just connected, but not actually sending or receiving messages, you can still end up paying a significant amount for these idle connections. I did a detailed comparison of these options when it comes to building WebSocket applications serverlessly, so please feel free to check it out and see how they compare based on pricing. I hope you're excited to learn more about Momento. I'm sure that once you know how it works, you'll become a valuable tool in your toolbox. So, without further ado, let me show you how to get started and what you can do with Momento Cache and the topics. To get started with Momento, just go to gomomento.com and register for an account. Go to sign in and then sign up. Enter your email or continue with Google, follow the steps. Once you are registered and signed in, then you can access the Momento console where you can create new caches. Again, you can create many caches and you're not going to get charged for them unless you actually use them. And one caveat to keep in mind is that because topics also use the same underlying infrastructure as caches, so when you want to create a new topic, you also do that by creating a new cache. And then to test your topics, you can use the console to subscribe to the topic so you can see what messages are published to the topic. We'll look at this later on when I show you how to use topics to build real-time notification and the chat application. You can also interact with Momento using the CLI, which you can install using Brew or Widget. The link to the CLI repo will be in the description below. Or you can use any of their supported SDKs for different languages. And to use the SDK or the CLI, you need to create new API keys, which you can do in the console. You can create either a super user key, which is what you need to be able to create and delete caches and topics, as well as to issue tokens to the front end. So the front end can also access the caches and topics directly. Again, we talk more about that later in the course when it comes to implementing those real-time systems. Or to issue API keys that just allows you to access the cache and the topics that has been created already, and make sure that I'm in the right region. So I can say I want to create a fine-grained access key that allows me to talk to the leaderboard cache, and you can say whether it's read-write or read-only or write-only. And you can set the expiration for the API key as well. And for backend processes, you also have the option to say don't expire the key, But generally speaking, it's better to have an exploration so that even if you're using the API keys from a backend process, you should have some mechanism to rotate the keys. After you add the permissions that you want the API key to allow, then you can go ahead and generate the API key. Okay, so that's how you can get started. In the next couple of lessons, I'm going to show you how to actually build applications using the Momento cache and the topic. With the Momento cache, if you go to Momento API references, you can see that it supports a number of different data types, very similar to what you find with Redis, including the sorted set, which allows you to implement things like leaderboard really easily. And that's the first example I'm going to show you. And then I'm going to show you how to use topics to build real-time notification system and a real-time chat application as well. Okay, I will see you in the next lesson. Okay, so for this first example, I'm going to show you how to use the Momento cache to implement a leaderboard service that allows you to submit scores for a particular user on the leaderboard. For example, for my score on the, say, Mario Kart leaderboard, and then to be able to also get my current ranking and score on a particular leaderboard, or to just get the first couple of users from the leaderboard based on their current rank. So for this example, I'm going to have an API gateway in front of a couple of Lambda functions, one for each of those routes. And we're going to use Momento cache, and I'm going to use the sorted set. And for those of you who have used Redis before, this is very similar to the sorted set API you have on Redis. And to submit a score, we're going to use the put element call, which takes the cache name and the name for the sorted set, as well as a value, which is going to be the name of the user and the score associated with that user. And we're going to use this API to submit our score. And then to get my current standing in the leaderboard, we have to make two separate calls, one to get my current score using the sorted set get score API. Again, that takes the cache name and the name of the sorted set and the value, which in this case is going to be the name of the user. So we're going to get back the score for the user, provided that we get a cache hit. But we also want to get the rank for this user as well. So we're also going to use the sorted set get rank API, which also takes the cache name, the name of the sorted set, and the value of the element, which is going to be the username. And we can say whether we want to sort the scores in ascending order or descending order. In this particular case, I'm going to say we're going to sort the score by descending. So higher score means higher rank. And if it's a cache hit, we're going to get back the rank, which is going to be an integer that's 0 indexed. And finally, for the last endpoint, to get the ranked players on the leaderboard based on their current rank, we can use the sorted set fetch by rank, which takes the start rank and the end rank as optional inputs. And again, we can say whether we want to sort the scores by ascending or descending order. And our API is going to return something like this as a response. And we're going to use CDK and the JavaScript to implement the whole thing. All the code for this example is available on GitHub, and you'll find the link down below. So in the next lesson, let's go over the CDK application and how we've structured everything. Okay, so first thing we're going to do is to set up our CDK app. And for that, you need to have installed the CDK CLI so you can use it to initialize a new project. Okay, so first we're going to make a new directory. Let's call this leaderboard service. And we're going to cd into it and then run CDK init. And we're going to use JavaScript. And it's going to go ahead and initialize a new project for us. And so let's open it up in the Visual Studio Code. So this is the default template that the CDK use. It puts your CDK app in the bin directory and then your constructs in the lib directory. I don't actually like this configuration because bin is not really binary, and the way the things are structured is like CDK is trying to take over the whole repo. I want to put my shared libraries in the lib folder, but it's just using it for your construct and other things for your CDK code. So I typically like to put all the CDK related code in a CDK folder so I can have a clear separation between code that's going to be executed at runtime and the code that's going to be executed when I build a CDK app. But for the purpose of this demo, I'm happy to just leave it as it is. If you want to see how I normally organize my CDK application, you can check out the repo that's linked below. But for now, we can also get rid of the test. Most of the CDK tests are not particularly useful. They just check whether or not you have created a resource. I find it much more meaningful to write tests for your application instead of your CDK application. But there are some situations where CDK tests can be useful. For the purpose of this demo, we are not going to need this. We can just go ahead and delete it. And we can also remove the test script. So here we have a CDK app, and it's going to create a leaderboard service stack. And so let's remind ourselves the architecture that we're aiming for. We're going to have API gateway in front of a couple of Lambda functions, one for each route, and they're going to talk to a Momento cache and use the sorted set APIs to allow you to submit a score, get your current standing, as well as the number of ranked players on the leaderboard. And for our functions to talk to Momento cache, we're going to have to also generate an API key and store it somewhere safe. I'm going to talk more about that in a minute. But for now, I'm just going to replace all of this code and then we can walk through what we're going to do instead. So first, we're going to declare a REST API in API Gateway. And I want the stage name to match a stage name that I'm currently working on, whether it's dev, test, staging, or some ephemeral environment that I'm using to develop a new feature. And I also want to enable X-ray tracing. And the name of the stage that I'm working in is going to come from the properties. And we're going to have a property called the stage name that's going to be set by the CDK app entry point here. And we're going to use that in our logical ID, which is then also going to be included in the name of the API when it's created by CloudFormation. And we're also going to have a service name in the properties as well as the SSM stage name. And we're going to use this. So this will be something like leaderboard API. And the SSM stage name will be something like a dev. This is so that if our stage name is, say, stage name is dev yen or dev feature 1024 for a temporary environment that we're going to use called dev feature 1024. But we don't want to duplicate our SSM parameters for every single ephemeral environment we're going to have. And so we can use this SSM stage name property so that we are able to have our ephemeral environment share the same SSM parameters as the main environment like dev. So later on, I'm going to generate a new API key from Momento, and then I'm going to put it into an SSM parameter. And I'm going to give my functions the permission to fetch this parameter from SSM parameter store. And we're going to go ahead and create some Lambda functions. They're all going to be configured the same. And so the only difference is the name of the module and the name of the function. So we have this helper function to create a new Lambda function with the logical ID, which again is going to be used to create the name of the function. And we're going to tell it where to find the function module. So this is going to look for a function module in a folder called functions. So we're going to go ahead and create that folder, functions. And we're going to have 3 modules for submit score, get standing, and get leaderboard. We'll fill this out a bit later, but for now, we just want to look at how we've configured our CDK app. So we're going to pass the service name, stage name, as well as the Momento key parameter name to our function as environment variables. And by default, CDK uses 128 meg of memory, which actually causes a lot of problems because even though your Lambda function may not use the all 128 meg of memory, by the time you use maybe 60, 70 meg, the OS level paging is going to kick in. And so your memory is going to get saved onto the disk and the back. And so that's going to have a big impact on your function's performance, both in terms of cold start, but also warm start as well. And for say 99% of the Lambda functions I've ever seen in production, 1 gig of memory is absolutely fine because they don't get invoked so frequently that the cost of those Lambda functions becomes an issue. Of course, if you know a function is going to get run all the time and you need to optimize the cost for that particular function, then by all means, use something like the Lambda power tuning tool to right-size the memory setting for your function. But as a default, 1 gig is absolutely fine, and it just means I don't have to worry about silly performance issues because of my function doesn't have enough memory. And of course, the function also needs to know the name of the cache that we have to talk to in Momento. So right now it's just hard-coded. If we want this to work with different environments and say with ephemeral environments as well, then this cache name would have to be say suffixed or prefixed with the environment name, or rather stage name. But for the purpose of this demo, it's good enough because I've created a cache called the leaderboard, and that's what we're going to use. And notice that I've got a power tools log level environment variable as well. This is because we're going to be using the Lambda power tools, and it comes with a logger. And so in this case, we are saying that for production, we want to set the log level to info so that our debug logs are not going to get recorded in CloudWatch. Because in production, we don't need all the debug logs, and it's best practice to not keep all of your debug logs in production in order to minimize the cost of CloudWatch. And finally, for our function to be able to fetch this parameter in SSM parameter store, we're going to have to give it a permission to call SSM get parameters against the ARN of the parameter. So more about this on how we're actually fetching the parameter a bit later on. We're going to use a middleware to do that for us. And we're going to cache the API key once we get it back so that we're able to, in the background, refresh the API key without having to redeploy our CDK application. And lastly, we're going to take those three functions that we have created to submit score, to get a standing, and to get the leaderboard. And we're going to pass it to this other helper function to actually set up and wire up the different routes in our API. The submit score function is going to be behind the post endpoint to submit a score for a user on a particular leaderboard, and the get standing for the get endpoint to fetch a user's standing in a leaderboard, and so on. So that's our stack for the leaderboard service. And let's go back to the CDK app itself. And since the stack is expecting some properties such as the stage name, SSM stage name, and the service name, we have to pass those into the stack. And the way I normally get this is to allow you to pass them in as context, so that for every deployment, you can specify the stage name and the SSM stage name. But in most cases, you're probably going to be just working on dev or using an ephemeral environment. And so where these are not provided, we can just default the stage name to dev. And where we are not overriding the SSM stage name, we can just default it to use the same stage name as well. But when we start working on a new feature, we can say, create an ephemeral environment called the dev yen. And we don't want to, again, duplicate all of the SSM parameters. So we can just set SSM stage name to dev instead. And we can do that when we use CDK to deploy our app or to synthesize our CloudFormation stack. At that point, we can pass in the context to override the default stage name and the SSM stage name. And the last information we need to provide is a service name, which you're going to call leaderboard API. And to avoid our stacks clashing when we have multiple environments running in the same account, so I'm going to suffix this with the stage name. And because the stack has the stage name as a suffix, all of the Lambda functions we're going to create in the stack will be prefixed with the name of the stack. And so they will all have the stage name in their prefix as well. So the last thing we're going to do here is to pass in the three properties that the leaderboard stack is expecting. Okay, and with this, we should be able to synthesize our stack. We're not going to deploy it just yet because we haven't implemented the functions, but we can run CDK synth to synthesize the stack. As you can see, it's defaulted the stage name to dev, as well as the SSM stage name to the current stage name as well, which is dev. And you can see that's the CloudFormation stack that's been generated, which we can also see in the cdk.out folder as well. So here's our API. Here's our API deployment, the stage, which is going to use the stage name dev, and then the leaderboard path, followed by the name path, and the lambda permission to invoke the function for submit score, and so on and so forth. And if we want to deploy this to a different stage, to say test or prod, then we can run cdk synth just to see what the stack is going to generate. We can say context stage name equals prod. In this case, it's going to default the SSM stage name to prod as well, because we haven't provided a context override for the SSM stage name. Okay, so let's look at our generated CloudFormation stack again. And now it's going to say stage for the API deployment is going to be prod. And we can look for the SSM parameter that it's going to look for. And it's going to look for a parameter called leaderboard API /prod /memento /API key. And what about if we were to say work on a feature? We're going to use a dev account. And what about if we want to use an ephemeral environment to work on a new feature? Then we can say stage name is, say, dev new feature. Again, we don't want to have to copy the SSM parameter for every single new ephemeral environment we're going to end up using. So I'm going to override the SSM stage name to say, just use the dev SSM parameters for this new dev new feature environment that I'm going to be using. Once again, let's check our generated CloudFormation stack. Now the stage name for our API is going to be dev new feature, but if we were to look for SSM, the parameter we're going to be looking for is still going to be the parameter from the dev environment. Okay, so that's the CDK setup. Next, let's look at how we can implement the submit score function and how we can fetch the SSM parameter at runtime. Okay, I'll see you in the next lesson. Okay, so now that we have our CDK application bootstrapped, let's go ahead and implement the submit score function. And to save you from watching me type all of that code, here's the code and you can find it in the GitHub repo linked below as well. So let's walk through what we're doing here. We're going to use a media middleware, which has SSM parameter middleware, which allows us to fetch the parameter from SSM parameter store, and it's going to cache it for 5 minutes. This is so that we're able to rotate the API key in the background and update the parameter in SSM without having to redeploy our application. If we were to include the API key as environment variable, then every time we rotate the API key, we will have to redeploy all of our functions. Plus, you don't want to keep sensitive information like API keys and the connection strings and the other things like that as plain text in environment variables, because imagine if any one of your dependencies has been compromised, there's a good chance that the attacker is going to use the module during initialization to scan your environment variables, because environment variables is a low-hanging fruit. We know people put a lot of sensitive information there, and so we've seen many examples in the JavaScript ecosystem where attackers try to harvest your environment variables, which is why with the SSM middleware, we also have the option to say, please set the Momento API key that you fetch from this SSM parameter, which we have passed in from the CDK app, where we set the Momento API key parameter name is going to be whatever we have configured here based on the name of the service, which is leaderboard API, as well as the current SSM stage name. So during cold start, and it's going to fetch the parameter, it's going to cache it for 5 minutes, and then 5 minutes later, for the next invocation that comes after, it's going to see that, oh, my cache value is stale, so I'm going to go back to SSM and fetch a new one. So if any time during these 5 minutes, I rotate the API key in the background and update the SSM parameter, then after 5 minutes, an instance of this function is going to go and fetch the new API key from SSM parameter store automatically. And because this submit score function is going to be sitting on the path of leaderboard name, where name is the name of the user and the leaderboard is the name of the leaderboard. So we're going to get those from the path parameters. Notice that I'm using JS docs to give me some IntelliSense support. Right now it's not really working because we haven't installed this package yet. So maybe let's do that first. For things like type definitions, we want to install them as a dev dependency because they're not intended to be used during execution time of our functions. But for the media packages, we're going to install them as production dependencies. But there is one caveat to keep in mind, that for MIDI, since version 5, they only work with ESM modules, which we're not doing right now. So for the purpose of this demo, I'm going to have to just use the older version of MIDI. Use version 4.7.0 for both the MIDI core, which is the middleware infrastructure, and the MIDI SSM package, which is the SSM middleware. Finally, you can see that I've got a reference here for Momento library. In fact, this is referencing this lib folder. Since this lib folder is being used by CDK for its constructs, I'm actually going to just create a new lib folder for our shared libraries for our functions. And so let's change this to this. And we're expecting, in this case, a Momento module. And we expect two functions, init client and the submit score. So I'm just going to copy everything that we would need in this shared module right now, including init client. The first time it runs, it's going to see that we don't have an instance of the cache client from the Momento SDK. Oh, I should also install this as well as a production dependency. And we're also going to be using the Lambda Power Tools logger, so I should install that as well. Again, as a production dependency, because this is a package we're going to use at runtime for our function. Okay, and we're going to extract the Momento cache name, which is something that we have set for our functions as an environment variable. And in this case, is hard-coded to leaderboard. Again, if you're going to be using this in different environments, you're going to want to suffix that with the stage name. Okay, but for now, let's look at this init client. During a cold start, we're going to initialize the cache client using the API key that we're going to fetch using the SSM middleware from SSM parameter store, which we have told to set this Momento API key against the context object instead of the environment variables, so we're able to access it from the context object. Again, this is so that attackers can't just scan our environment variables and find our Momento API key. So every time the function runs, it's going to call this init client, which the first time it runs is going to see, oh, we don't have an instance of this cache client, so we're going to create it so that on subsequent invocations, we're not going to do this initialization ever again. We're going to log some info messages to say we are initializing the Momento cache client and we finished initializing the client. And after we've initialized the client, we say, please submit score with the leaderboard name and the name. And then we're expecting a score attribute in the body to our post endpoint. And it's going to take that and it's going to call Momento's sorted set put element API and pass in the name of the cache, which is going to come from the environment variables, the leaderboard name, the name of the user, and the score that we want to save. And if it's error, then we log the error and we rethrow the inner exception. So in the submit score function, if we see any error, we're going to return a 500 instead and just return a generic message that says failed to submit score. And for this function to work, the SSM parameter needs to be in place for the dev stage. So we need to go to Momento, generate an API key. Our function just needs to access a cache. It doesn't need to administer the cache itself. So we can use a fine-grained access key and make sure we're in the right region where the cache is declared. Leaderboard, and I can set this to be 7 days. And because of the expiration is 7 days, so I need to have some mechanism to rotate the API key maybe with a cron job and the Lambda function to generate a new API key, which you can actually do with the Momento SDK itself. So you can actually use the SDK to create a new API key. So in that case, that function will need a super user key. So it's able to use that key to then generate new keys for itself, but also for the functions that we have in this leaderboard API. So in this case, we will need to be able to read and write. So we can add the permission and generate a new API key, capture that, and then save it into our SSM parameter, which I've done already. So if you look at this leaderboard API dev Momento API key already exists, is stored as a secure string. So we're able to deploy our CDK app, and that should create a new endpoint that we can use to test this new submit score endpoint. So let's go ahead and do that. CDK deploy. And this would have defaulted to the dev stage name and the dev SSM stage name as well. Yes. So that's going to create a new stack called the leaderboard service stack dev. Okay, it failed because some functions are actually empty and that's not allowed. So what we have to do is for now, just module.export.handler equals async. Just going to return an empty function instead. Okay, try this again. So the reason it happened is because we were using the Node.js function construct, which actually bundles our function. So if the entry module is empty, then there's nothing to bundle, and so it generates an empty package. So hopefully now it will go through. Okay, so that's gone through. So we can capture our API endpoint, and we can test this out quickly using Postman. So let's paste in our endpoint and name the leaderboard. Let's call it Mario Kart, and the username is the Burning Monk. So the endpoint is expecting a JSON body like this with just a single score attribute. It's not authenticated, and we can see the response coming back as 202 accepted. And we can actually go check out this sorted set in our cache using the Momento console, caches, leaderboard. And we can look up the key, Mario Kart. There you go. That's the Burning Monk user with the score 27. All right, so in the next lesson, we're going to implement the getStanding function as well. It's going to look very similar to what we've done with the submit score function. Okay, I'll see you in the next lesson. Okay, so now that we have implemented the submit score endpoint, let's go ahead and implement the getStanding endpoint. So here's the code. Again, you can find all the code in the GitHub repo that's linked below. And as before, this function is sitting behind a path with a leaderboard path as well as a name path parameter, and it's a get endpoint. And so we can get the leaderboard name and the username by checking the path parameters. And we're using MIDI's SSM middleware to fetch the Momento API key from SSM parameter store, cache it for 5 minutes, and we're going to set it to the context object instead of the environment variables. So we're able to access it from the context object instead. And we're going to call the shared Momento modules init client function. Oh, this is a wrong path. Init client. So during a cold start, it's going to create an instance of the cache client. And this is an example of in-memory caching inside the Lambda function itself, because after the invocation finishes, the Lambda execution environment is going to be frozen, but then any global variables that you have created will still be in memory when the execution environment is thawed on the next invocation. And in this case, our getStanding function is going to call a helper function called getScoreAndRank, and to fetch the score and the rank of the current user on this leaderboard. Instead of making these two calls one after another, I've prematurely optimized a little bit here to make those calls concurrently. And the reason why we need to make two separate calls is because the Momento's sorted set API doesn't have one single call that allows you to fetch both the score and the rank for an element in the sorted set. So instead, we're making two calls to the cache, one to get the score, and if it's a hit, then we return the score. If it's a cache miss, then we return 0 because this user doesn't have a score on the leaderboard yet. For any other errors, we're going to log the error and then rethrow the inner exception. And to get the rank of the user, we are using the sorted set getRank API. And we say, please give us the rank of the user by sorting the scores in descending order. And if it's a cache hit because the user exists in the sorted set, then we return the user's rank. Otherwise, return no. And if there's a legitimate error, then we're going to log it and then rethrow the error. And if either of these calls throws an error, then this promise.all is going to error as well. But if everything's good, then we can deconstruct the return values from these two async function calls to capture the score and the rank of the user and return that as a single response to the getStanding function. And then we're going to return that as a 200. And again, if anything goes wrong, we're going to handle the error by returning a 500 instead, with a generic error message that says failed to get score and rank. Once again, we can deploy this, and it's going to update the getStanding function behind that path, and we'll be able to quickly test it out. Okay, so the deployment is done. So let's grab our URL again and go back to Postman. So the score that we saved last time was on the Mario Kart leaderboard, and the user was called the Burning Monk. So let's call this endpoint to get the standing for the Burning Monk. Because I'm the only user on the leaderboard, so I'm coming back with rank as 0, which is first in the leaderboard. Rank is 0 indexed, as well as my score. But if I was to look for a different user, say Silverhand, then the user doesn't exist on the leaderboard, so score is going to come back as 0 and the rank is going to be no. Okay, so that's working as expected. So in the next lesson, we're going to implement the getLeaderboard function as well. Okay, I'll see you in a bit. Okay, so the last function we're going to implement in this leaderboard service is the getLeaderboard endpoint or function. Exactly the same structure as before. Oh, wrong path again. Same structure as before, because this function is sitting behind the endpoint slash leaderboard. So we're able to get the leaderboard name from the path parameters, but we're expecting the start rank and the end rank optional arguments to come in as query string parameters. So we're going to fetch them from the query string parameters instead, and the default to undefined if they're not there, because pass in will return not a number instead if you give it a null or undefined. And exactly the same as before, we're using the SSM middleware to fetch the Momento API key from SSM parameter store and caching it and saving it into the context object, which we're using to initialize the cache client. And then we're calling the getLeaderboard helper function in the shared Momento module with the leaderboard start rank and end rank. And here we're using Momento's sorted set fetch by rank API that takes the cache name, the leaderboard name, or rather sorted set name, and some arguments that includes the start rank and end rank, where start rank is 0 index. So if it's not set, if it's undefined, we're going to just pass in 0 instead. And once again, we have to say in what order do we want to rank the players based on their score. And so I'm going to use descending order in this case. And if it's a cache hit, so we have some values at least in the sorted set, then we're going to grab the cache, grab whatever's returned, and turn that into an array of objects with name and the score. If it's a cache miss, that means the sorted set doesn't exist, it's empty. We don't have a leaderboard by that name, so we're going to return an empty array instead. Any other errors, log it and rethrow the inner exception. And that's our getLeaderboard function. which we're going to return as a 200 response with the leaderboard as the array of name and the score values. Okay, let's go ahead and deploy this. And once the deployment is done, we can go ahead and test it out in the Postman again. Okay, the deployment is done. Let's grab our URL again and go back to Postman. So the leaderboard is called Mario Kart, and we want, if we don't pass anything, it's going to just return all the players in the leaderboard with a start rank of 0. Or maybe not, internal server error. What if its start rank is 0? Okay, so that works. Let's go to our Lambda function and see what the error was. As you can see, leaderboard service tag. Oh, the def suffix has been was truncated, so that's not very good. We may need to shorten the name of the stack, or maybe shorten the name of the function. But in any case, we're looking for the get leaderboard function. Let's go to CloudWatch logs and see what the error was. Okay. Cannot read property of null, reading start rank. Okay, so somewhere in our code, right, okay, so where there is no query string parameters at all, query string parameters is going to be null. So we probably need to do something like this instead to handle that case. Let's redeploy, and hopefully that fixes the problem. Another thing to consider here is that, well, we probably don't want to return every user on the leaderboard. So where end rank is not provided, maybe we want to default it based on the value of start rank. So if start rank is 0, then let's say we're always going to just fetch 100 users in one go, or maybe even less than that. Could be just 12 users on the leaderboard. So end rank would be start rank plus 12. For the purpose of this demo, we can just ignore that. But if you're building a leaderboard service for real, then that's something that you want to keep in mind. Okay, that still works. If we don't provide any query string parameters, still internal server error. Maybe we need to do this. One more time. And if we were to check the logs in the meantime, yep, same error, cannot read property of null. And notice that the stack trace, and this is kind of gibberish because we're not bundling the source map. And that's one of the trade-offs you have to think about when it comes to bundling your JavaScript functions. If you don't include the source map, then you're going to get line numbers that doesn't make any sense. But if you do bundle your source map, then that can have a big impact on your cold start performance because the size of the artifact can be significantly bigger. Okay, let's try this one more time. Okay, now it's working. And one more test, if we were to try a different leaderboard, Mario Kart 2, then it's going to return an empty array instead. So it looks like everything is working as expected. So in this chapter, we saw how you can use Momento cache, specifically the sorted set collections, to implement a leaderboard service. And it's mostly a case of initializing a cache client from the Momento SDK and using it. The most challenging thing about it is more around handling the API keys. We saw how to generate fine-grained API keys in the Momento console. We talked about how to rotate them and how to store them somewhere safe, like SSM parameter store or secrets manager, where we can use KMS to make sure they are encrypted at rest. And why, instead of putting them in plain text in environment variables, we should load them at runtime using something like MIDI and its SSM middleware. But all that just covers the use case where our backend are the only ones that need to talk to Momento, and that's likely the case for using the Momento cache. But what about Momento topics? A common use case is to have the front end subscribe to a topic so we can push real-time updates to the front end via WebSockets. In fact, that's one of the common use cases for WebSockets, where the user can kick off some long-running process from the front end, and the backend is going to queue that up and process it asynchronously, so we can respond to the user right away, and they can get on with doing other things in our app. And so the front end can subscribe to a Momento topic, and when our background process is done, we can push the update to the front end through the topic without needing any sort of API polling. And that's what we're going to do in the next chapter. And I'll show you how to allow the front end to connect to Momento safely and securely. Okay, I'll see you in a bit. Okay, in this second example, I'm going to show you how to use Momento topics to send real-time updates to your front end, and how to allow the front end to securely connect to Momento. To support this kind of flow, Momento's SDK actually has support for generating a disposable token, which is designed for you to give to the front end and say the front end can use this token to connect to Momento and maybe access a specific cache or a particular key in the cache, or in our case, to subscribe to updates to a Momento topic. And we can say whether or not they have the ability to just read from the topic or to also publish to the topic as well. And in this particular case, what we're going to do is we're going to simulate the user kicking off a long-running process that takes a few seconds to complete. And so we're going to put that onto a queue and then have a background function pick up the task and just wait for a few seconds before sending a complete message to the topic. And that update will be pushed to the user via WebSocket. And the important thing here is that every user in our system should be able to receive only updates for their tasks, and they can't subscribe to somebody else's updates. And this is where the disposable token is going to come in, so that we lock it down to the specific topic that the front end is able to subscribe to in Momento. And once again, we have API endpoint in API gateway with two routes. One route to get the disposable token. So in this case, we're going to use Cognito to authenticate the user, and we're going to have a Cognito authorizer on API gateway so that when the front end calls our API, they have to pass along the ID token from Cognito. And with that, we're able to get the user's unique ID and generate a token that only allows the front end to subscribe to a topic that's named after that user ID. And when we finish the background task, we're going to push an update to that user's topic. So only the relevant user is able to get that update. And as with the previous example, let's start by looking at how we can set up the CDK application. Okay, so for this second example, we'll do the same thing as we did before. First, make a directory. So let's call this notification service, cd into it, and open it up in the VS Code. And the first thing I'm going to do is to use a CDK to init the project with JavaScript. Again, I'm not particularly fond of this configuration that CDK has, but for the purpose of this demo, I'm just going to ignore it. If you want to see how I normally set up my CDK applications, feel free to use the link below to check out the demo app. So here we have a CDK app, and then we have the notification service stack. So the first thing I'm going to do is to just implement this stack. And let's quickly go over what we are doing here. If you remember from the last example, we have done something very similar here, where we set up a REST API, and we take a stage name from the properties, and we enable X-ray tracing. But in this case, we want the endpoints to be authenticated with a Cognito user pool. So we're also going to create a user pool as well. We want the user pool's name to have our service name and the stage name. And we want users to be able to sign up themselves and to be able to sign in using email. We're going to set up a user pool client so the front end can use this client ID to sign in with Cognito. And we're going to add some CloudFormation outputs so that we can more easily capture this information later as we're going to need it for our front end. And as before, I'm going to generate a Momento API key and I'm going to save it into SSM parameter store. What's different in this case is that instead of a fine-grained API key, we actually going to need to create a super user key because our backend needs to generate disposable tokens, and for that, you do need a super user key. So I'll talk more about that later on when we get to it. And as we discussed before, when we talk about the high-level architecture, we're going to have an endpoint that takes a user request and just puts it into a queue. And so we can process it in the background to simulate a case when the user kicks off a long-running process so that we can then push them updates via the Momento topic. So here I'm introducing SQS queue and a function to process messages from the queue. As with the last example, we included a bunch of environment variables, including the name of the SSM parameter, where we can find the Momento API key, as well as the Momento cache name and the log level to use with the Lambda Power Tools logger. And here we are going to attach the SQS event source to our function, and we're going to enable report batch item failures so we can handle partial failures. It's not really necessary in this particular case, but this is just standard best practice you should be doing when you're processing SQS queues. To learn more about handling failures when you're processing events asynchronously, check out this other video that I'm going to link below. And finally, for this function, we're going to also need to fetch the parameter from SSM, so we are going to attach an inline policy for this function as well. So going back, we are going to also create another function as part of our API endpoint to say, put the task onto a queue. So here we are going to create a queue task function, more or less the same set of environment variables, except this function doesn't need to talk to Momento. So it just needs to know about the URL of the queue. So it's able to use the AWS SDK to put the message onto the queue. And of course, it needs a permission to do that. And lastly, this is the function that's going to be sitting behind the token endpoint, which is going to be responsible for issuing the disposable token to the front end once the user has been authenticated. So it also needs to know the Momento API key and the name of the cache. And therefore, by extension, it needs to be able to fetch the SSM parameter as well. And then finally, we're going to set up our API endpoint. And this is to set up the Cognito authorizer using our user pool, and the task endpoint is going to use this Cognito authorizer. And because we're going to actually have a front end calling our backend in this case as part of the demo, so we need to enable some CORS settings so our front end can talk to the backend API. And the same goes to the token endpoint, which is going to be protected by the Cognito authorizer, and it also needs to have some CORS configuration as well. Okay, so that's the API stack. Oh, right. I've hard-coded the Momento cache name as with the previous example. If you want to suffix this cache name with the name of the stage so that when you deploy to multiple stages, you will use a different cache. And another thing that we can do to improve the security of this whole setup is to have different API keys for the different functions. For example, the token vending machine function needs to issue a disposable token. And so this is a function that needs a super user key from Momento. But the background function that processes SQS messages and pushes them to Momento doesn't actually need to generate disposable tokens. So this can actually just use a fine-grained access key. For this demo, I've just combined the two. But if you want to make things more secure, then it's definitely better to have different keys for different purposes. And we also need to update our CDK app. And as we did for the previous example, we're going to get the stage name and the SSM stage name from the CDK context. And we're going to default them to dev if you don't provide one. And we're going to set the service name to notification API. And so the only thing we need to do here is to pass that information along to the notification service stack. But as we saw in the last demo, the stage name actually got truncated in the Lambda function names. So we can probably shorten this to just notification service followed by the stage name. And that's going to be the name of our stack. And all the functions that are created by this stack is going to have that same prefix. So that's our CDK setup. Before we can actually generate the CloudFormation stack, we actually need to just put in some placeholders for the functions we have here. So all of these functions are going to be looking for a module that's in the functions folder. So let's go ahead and create that. queue task, and we're just going to put in a placeholder so that the bundling process has something to use to generate an output file. And then the process task, just copy and paste this. And the last one is called the token vending machine. Okay, so with this, we should be able to run CDK synth to generate a CloudFormation stack. Okay, so the CDK app is set up. In the next lesson, let's see how we can implement the token vending machine. So in this lesson, we're going to implement the token vending machine function. And to save it from watching me type everything, here's the code. And as before, you can find all the code for this demo app in the GitHub repo linked below. And same as we did in the last example, we have all the Momento related logic in the share module in the lib folder called Momento. And here's the code for that. And as before, we're going to use the Momento SDK, but slightly different from the last example we saw where we just used the cache client to interact with the cache. So here we actually need to have two different clients, one for interacting with the topic so that our background SQS function can then use this to push updates to a user's topic. But we also need a different off client so we can use it to generate a disposable token. So essentially, we want to call this generate disposable token endpoint, which allows us to specify what permissions the front end should have in terms of caches that you can access or topics that you can access, and whether or not it can do both reads and writes or just reads in this particular case, because the front end just needs to receive real-time updates from the backend. It doesn't actually need to push anything to the topic itself. But for any of this to work, we have to first install all the necessary npm packages. So let's go ahead and do that. For the production dependencies, i.e. the packages that we actually need to run in our Lambda function, we will save them as production dependencies, including the Momento SDK and the Lambda Power Tools logger, but also MIDI as well. And again, because since version 5, MIDI only supports ESM modules, which we're not doing here, so we are stuck with version 4.7.0, which is the most recent version that we have before the ESM switch. So we do that for both the MIDI core, which is the actual middleware infrastructure, as well as the SSM middleware for fetching parameters from SSM parameter store. But also we're going to include HTTP CORS middleware as well, so that it will add those CORS headers on our HTTP response. So we will install all of this. And we also need to install the types package for AWS Lambda, so we have better IntelliSense support. This is so that we can get things like event.whatever and get autocomplete support for the invocation event. Okay, so now everything is installed. Let's go through the code for this token vending machine function. First thing we do is to initialize the off client in Momento. And so if we go into that and look at the init off client, this is very similar to what we did in the last demo app, except we are initializing an off client instead of a cache client, and we are using the API key that's provided from the context object, which in this case is set by the SSM middleware and taken from the SSM parameter, and is cached with a 5-minute expiration. And we told the SSM middleware to set it to the context object instead of the environment variables. And in this case, this is an authenticated endpoint, so we can find the user ID or the user's sub incognito by inspecting the invocation event, authorizer, claims, and .sub. And we can use this as the user ID. And once we have that, we can then use the Momento off client to generate a disposable token. And we can say with this token, we allow the user to interact with Momento topics, but only to subscribe against a particular cache and a topic name that's named after its user ID. There are other options to say topic, subscribe only, or publish only, or to both publish and subscribe. So if we were to subscribe only, we can provide a name or a pattern for the cache, as well as a name or a pattern for a topic name. In this case, we want a topic name to be the user ID, and we can set an expiration for the token as well. If there's any error, then we will log the inner exception and then rethrow it, so that in our token vending machine function, we will just return a 500 with a generic error message. Otherwise, we can capture from the result the endpoint, which we don't really need, but what we do need to return to the front end is the token, the cache name, and when the token is going to expire. And we will return all of those things in the HTTP response along with 200 status code. And because this is talking to a front end that's going to be hosted in a different domain perhaps, so we do need to use CORS, and that's where the CORS middleware comes in from MIDI. Okay, so that's the token vending machine function. We can't really easily test this because it's an authenticated endpoint, but once we've implemented all the functions, I can show you the front end code and we can test them by running the front end locally. Okay, I'll see you in the next lesson. Okay, for the next part of our application, we are going to implement the Lambda function that's going to take a user request and put it in a queue, and then for another function to pick it up from the queue and process it. And when it's done, send an update to the user's topic in Momento, and so the user can receive the update via push notification using the WebSocket connection they have to the Momento topic. So for that, we need to implement the queueTask function, which, as a reminder, is sitting behind the API endpoint for task. And this is again another authenticated endpoint. So we know the user's cognito sub, and we can use it as the user ID. And that's important because that information needs to go into the queue so that the background function, when it processes the message asynchronously, it knows the user ID. And so it knows what topic to send the update to in Momento. And I've just copied over the code. As before, you can find all the code for this demo application in the link below. As you can see, this code is not very exciting. All it's doing is using the SQS client to send a message to a queue whose URL we have passed in via the CDK, via environment variables, which I've configured in the CDK right here. And in the message body, we are including the user ID as well as the payload, which is just basically whatever the front end has sent us in the post body. If all goes well, we return a 202, otherwise we return a 500. And again, we're using MIDI's HTTP CORS middleware to inject those CORS headers to our response. And in this case, we also need to install the SQS client from the AWS SDK. We're going to do that as a dev dependency, because the AWS SDK exists in Lambda's execution environment already, so we only really need it for local development and if we ever try to run our function locally or as part of a test. So npm install save dev client SQS. Okay, so that takes care of the queueTask function. Next, we need to implement the processTask function. So this function needs to use the Momento helper in order to send a message to the topic. But let's go back here first. This is a SQS function, so we're going to receive an array of SQS records. For each of these records, we can extract the message body, which, if we go back to the queueTask function, is going to be a JSON structure that includes a user ID and a payload. So we pass the JSON, and we're going to use the user ID when we send the update to the user. But to grab the payload, I'm going to assume the payload is going to be some kind of JSON structure. So I'm going to JSON parse it and just add a debug message to say we are processing the message. We're not actually going to do anything here. We are just going to simulate this being a task that takes a few seconds to complete. And that's why we're implementing this whole system to send you updates asynchronously so that our API function, the queueTask function, can return to the caller right away. and then we're going to use WebSocket to send you updates to let you know when the task has been complete. So after we sleep for a few seconds, we're going to publish an update to the Momento topic. And that means we need to make sure that this function is going to use the SSM middleware to get the Momento API key. It's going to cache it for 5 minutes, and it's going to set the API key to the context object. We need to first initialize the Momento client, in this case, specifically the topic client from the Momento SDK. And this client allows us to send messages to a topic. And this helper function we have here in the Momento module is going to take a topic name and a value to push to the topic. So it's going to use the topic client to send a message, to send it to a topic in a cache. And we've hard-coded the cache name, and it's going to come from the environment variables. And we're going to send a topic name as well, which in this case is going to be the user ID. And whatever value that we are sending from the process task function, right, which is just going to be a string. So in this case, we are saying in the post body, we're expecting something like this. So that's what we're expecting in the post body from the task endpoint. So when we are done processing that task, we're going to just send a message to the front end, and the topic name is going to be the user ID. So as you can see, it's really easy to push updates to a front end using WebSocket when you use Momento topics, and the front end can subscribe to the topic also using the Momento SDK. And when you do, you get WebSockets, and with that connection, we can receive all these updates from the backend without doing any kind of polling. So in the next lesson, we're going to look at the front end code and see how we can use the token endpoint to get a temporary disposable token that allows us to subscribe to our user-specific topic and wait for the background Lambda function to send us updates when our task is complete. Okay, I'll see you in the next lesson. Okay, so moving on to the front-end side of our demo application, this is what we're going to have. Just a very, very simple page that allows you to sign in and out with Cognito, and then you can put a message, submit it, which is going to hit the task endpoint that we set up in the previous lesson. It's going to queue the task, process it, and then when it's done, we receive an update via the Momento topic. So we saw the pop-up just now. So to show you how to subscribe to the Momento topic from the front end and how to get the disposable token, we need to set up the front end application. So it has the Cognito user pool ID and the client ID, as well as the URL for our API. And again, all the code for the front end is also in the repo for this demo app and is linked below. And to get this information, we need to first deploy our backend application. So let's go ahead and do that. CDK deploy. It's going to default to the dev stage. And as I mentioned earlier, for this application, because we are going to issue a disposable token, so we need to use the super user key. So once you're logged into the Momento console, you can go to the API keys page and choose super user key, and make sure you're choosing the right region where your caches are, and then pick a suitable expiration time for your API key and hit generate. And once you have that, you can put it into SSM parameter store or secrets manager, which I've done already. And this is a secure string parameter, so it's encrypted by KMS. And so in the console, you won't see it. And I'm not going to show you my API key. And because I've done this step already, our functions, once deployed, will be able to read this API key from SSM parameter store. And so once the CDK deployment finishes, we can go ahead and grab those information and put it into a .env file for our front end. Okay, the deployment is finished. So let's grab this information. We need the user pool ID, the user pool client ID, and the URL for our API. Gonna leave off the trailing slash. And now within this Vue.js project, I can run npm run serve, and that should start a local instance of my front end running on the port 8080. Okay, so over here in the local host 8080, we have the option to sign in and to create a new account. So before we do that, let's just quickly go over what the front end looks like. And this is a Vue.js project. So as you can imagine, there's the app.vue file, which is the entry point for the application. And I'm using the Amplify's UI package for Vue.js. And this is the authenticator view that Amplify provides out of the box. And for this to work, in the main, we have to import the Amplify instance from the AWS Amplify package, and then to provide a configuration. And so if you go to the AWS exports, this is using Amplify Gen 1 version 5. The configuration for Gen 2 is slightly different, and I've not been able to get the Gen 2 to work correctly just yet, which is why we are still using Amplify version 5, as you can see in the package.json. So this is the Amplify version 5.3.21, not the latest version 6.x, which is Gen 2. So I'm saying in my configuration, please look up the user pool ID, client ID, as well as the API URL from the .env file, which the Vue runtime is going to load by default. And if you were to deploy this front end using Amplify hosting, you can also set these environment variables in your Amplify hosting configuration as well. And for those of you who have heard of Amplify before, but maybe only in the context of using Amplify CLI to create your resources, as you have seen for this project, we didn't use Amplify to create any of our backend or even Cognito. So with Amplify itself, it's actually multiple things all in one. You have the Amplify CLI, which you can use to create backend resources such as Cognito, but you don't have to use it, and you can also just use Amplify for the front-end components, such as the UI component for the authenticator. Or you can use the Amplify libraries to talk to Cognito for authentication and so on. And it also provides a package for GraphQL client and the HTTP client and so on. There's also the Amplify hosting service, which you can just point to a GitHub repo for your React or Vue or Angular or whatever front-end framework. And you will just take care of deploying it for you. And you can manage the domain names and so on and so forth. In this front-end project, I'm just using the Amplify packages, including the UI component for the authenticator. And so once the user is authenticated, I'm going to show them this input form, which is that basic input box we saw, and the submit button. And what we're doing here is when this input forms component is initialized, we find the current logged in user, get the JOT token, and then make a request to the token endpoint, which is going to hit the token vending machine Lambda function. And if you recall, this function returns the token results, which includes the actual token that you can use to talk to Momento, the name of the cache, and when the token is going to expire. So here in the front end, we're extracting the token and the cache name, and we're using it to subscribe to the Momento cache. And again, I've got a helper module here for talking to Momento, and it's going to use the Momento SDK, but for the web, to initialize the topic client. So in this case, I'm going to take the disposable token we got back from the token endpoint to initialize the client. And once initialized, we are going to call the subscribe method against the cache. And we're going to use our user ID as the topic name. As you can see, for this method, the second argument is the name of the topic. So as the backend is going to push update to a topic with our user ID, we're also going to subscribe to that topic with the same name. And in this case, when there's a new item arriving, I'm going to just call this onMessage function that gets passed into this subscribe to topic function with the value of that item. Otherwise, we're going to just pop up an alert with the message that we received some kind of error message from the Momento topic. Okay, so that's in the input form. And so when we're calling this subscribe to topic helper function, we are providing a function that takes the message from Momento, and we're just going to create a toaster message, which is created using this Vue toaster module. And then we're going to show it. And that's what we saw earlier with the little pop-up in the corner. And when we click this submit button, this is going to call this submit data function, which uses the auth module from the Amplify package to get your current logged in user's session. And so we can get the ID token and the JOT token so that we can use that to call the task endpoint, which, if you remember, is an authenticated endpoint, both the task endpoint as well as the token endpoint. And that's why we have to pass our job token as a bearer token in the authorization header. Okay, so that's the front end. First thing we're going to do is to create a user. And I'm going to use my theburningmonk.com email, set a password. Create account, and this is going to send me an email with a verification code, and it's going to be 727047. Confirm. Okay, so now that we are signed in, let's open up the network tab so I can show you what happens when we type a message and say submit, and this is going to hit our task endpoint. And in the background, it would have subscribed to the Momento topic. And when the background SQS function has finished processing the message and sent us an update, that's when we saw that pop up. Let's do another one. So after 5 seconds, yep, there you go. And if you look at the payload that we're sending to the backend, that's exactly what we said we were going to expect from the payload, which is a JSON with a data attribute. And so that's the front end. As you can see, it's really easy to subscribe to a Momento topic from the front end. You just need to call one of your endpoints to get a disposable token, and then use that token to subscribe to a cache with a topic name. And in this case, our token only allows us to subscribe to a topic whose name is our user ID, or our cognito sub more precisely. Then that's it. It just takes a few lines of code, so it's really easy to implement. And yes, the front end is pretty basic and pretty ugly, but it does the job. And all I wanted to do was to show you how you can implement this common pattern for using WebSocket, which is to receive notifications from the backend when some background process has finished. And we can use WebSocket to push updates to the front end, so we don't need to implement any kind of polling. So in this chapter, we saw how you can use Momento topics to allow backend processes to push real-time updates to the front end, which is one of the most common use cases for WebSockets. We saw how you can create super user keys and how they differ from fine-grained access keys, and how to generate disposable tokens so we can allow the front end to access Momento resources and subscribe to a Momento topic. But WebSocket and Momento topics can do more than just letting you push updates to the front end. In fact, you can build a real-time system where the clients can communicate with each other through shared Momento topics. For example, a real-time chat system like the one that we're going to build in the next chapter. Okay, I'll see you there. So in this chapter, we're going to build another demo example. This time it's going to be a real-time chat application that allows you to join different chat rooms and start having conversations with other people in the same chat room. And the messages are instantly sent to everybody else. Hello back. By using Momento topics to facilitate client-to-client communications, so that each of these clients are connecting to a topic that's tied to the name of the chat room. And as we type and send messages, those are then automatically sent to everybody else connected to the same topic. And so on the backend side of things, we are once again going to have API gateway to provide a number of endpoints. In this case, we are just going to have 2 endpoints to facilitate adding new chat rooms. So I can add a chat here for test. So this is going to add a new chat room. Unfortunately, I'm not pushing any updates, so that on this side, you have to refresh to see the new chat room. And then there's also an endpoint to list all the available chat rooms. So if I refresh here, we can see the new chat room has shown up here. So if I go to test, and same here, the messages are being published to everyone that's connected to this new chat room. And we're going to have a DynamoDB table to store the available chat rooms. As we did in the previous demo app, we're going to have a token vending machine function to issue disposable tokens to the front end, so we are able to then subscribe to the different chat rooms. Each one has got its own Momento topic. Disposable tokens allows the front end to subscribe to those topics and receive updates via WebSockets whenever any of the clients publish a message to the topic. So in this case, the disposable tokens need to give the front end the permission to both publish and to subscribe to topics. And we'll see how that looks in our code pretty soon. But first, let's look at our CDK app. Okay, so by now you know the drill. First, we create a new directory for our application, chat app, cd into it, open it in Visual Studio Code, and we're going to use CDK to initialize the project with JavaScript. And I'm going to get rid of the test folder because we don't need it. And once again, you can see all the code for this demo application in the GitHub repo linked below. And first, we're going to update our chat app stack into this. And let's walk through this again. As before, we have hard-coded the Momento cache name and have the cache set up in Momento already. So if you go to the Momento console, you can see the chat cache. Once again, we are not going to use the cache, we are just going to use the topics, but because topics share the same underlying infrastructure, so when you want to use the topic, you have to first create a cache in Momento. And if you want to use different cache for each environment, then you want to suffix or prefix the name of the cache with the stage name. And so we have set up a new API called stage name chat API. We set up a cognitive user pool because our API endpoints are going to be authenticated. And we have a cognitive user pool client. We output the user pool ID and the client ID so we can easily find them later for the front end. And we're going to keep the API key in SSM parameter store in the same naming convention as before. Service name, SSM stage name, and the Momento API key. And as with the previous example, because we have to issue a disposable token, we have to use a super user key instead of a fine-grained access key. And for this demo, because we're going to need to keep track of the chat rooms in a DynamoDB table, so we are also going to create a new DynamoDB table as well. It's going to use the paper request billing mode, so we're not going to pay for any uptime for the table, only for the request that we pay to read and write to the table. And we're just going to have a simple hash key for the chat name. This is just so that you can't create multiple chats with the same name. We are going to have 3 functions. One to list the available chats, which just needs to know the name of the table. It doesn't need to talk to Momento, so there's no need to know the Momento API key. Another function to create a new chat, which again just need to know the name of the DynamoDB table. And lastly, a token vending machine function, which does need to know the name of the Momento cache and where the Momento API key is in SSM parameter store. And it will also need the permission to get that parameter from SSM as well. But with the other 2 functions, they just need to have the read permission to list the chats and the write permission to save a new chat into the chats table. And we're going to hook up those endpoints in our API. So we're going to have a chats post endpoint that lets you create a new chat, and it's going to be authenticated with Cognito. And we're going to have a get endpoint for the chat path as well. This is to let you list the available chats, and once again, authenticated by Cognito. And in both cases, because they are part of the same path, we can just add the calls to the chat's resource instead of the individual endpoints. And we're going to have a token endpoint as well that's hooked up to the token vending machine function, which once more is authenticated by Cognito and it needs some coarse treatment as well. Okay, so that's our chat app stack. Going back to the CDK app itself. As we've done many times already in this course, we're going to get the stage name and SSM stage name from the context. We're going to default them to dev if they're not provided. And we're going to set the service name to chat API and pass all 3 of this to the chat app stack. And for now, we're going to put some placeholders for those 3 functions that we're going to have to create later. So new chat, and it's going to need a placeholder handler. And I think it's called the list chat. List chat, and then token vending machine. Okay, so that's our CDK app done. Next, let's go ahead and implement all of those functions. Okay, I'll see you in a bit. Okay, so let's go ahead and implement our token vending machine. And this is basically the same code as last time, where we're going to have shared lib module, shared Momento module, which is going to use the Momento SDK, and it's going to initialize the instance of the auth client so we can use it to generate a disposable token. The only thing that's different this time around is the scope of what the user is allowed to do. So if you remember, in the last example, we only need to subscribe to a topic from the front end. We don't need to publish anything to it. But for the chat app, the front end is going to subscribe to a topic, but also publish to it as well. And so we need to allow the topic publish and subscribe against the cache that we have set up for this app. But also importantly, in the last example, the user can only subscribe to their own topic to receive the updates. But in this case, because you can create new chats, we really don't know what topic names there are going to be. So we're going to allow you to subscribe to all topics instead. And as before, we're using MIDI to handle calls and also to fetch the Momento API key from SSM parameter store and caching it and setting it to the context object instead of environment variables. So once again, we have a bunch of things that we need to install as npm packages. So I'm just going to save the dev dependency for the lambda types package first. And then I'm going to install the MIDI core, and again, has to be version 4.7.0 because of the ESM change for version 5. The SSM package for the SSM middleware, and the HTTP course package for the course middleware. And we also need to bring in the Momento SDK and the Lambda Power Tools logger. Oh, just realized I've got a typo here. That should say chat API instead of a leaderboard API. Oh, and one thing I forgot to do in the last lesson was to name this stack with a suffix, with a stage name. Okay, so that's the token vending machine endpoint. For the list chat endpoint, we're going to need something like this, where we're going to use the AWS SDK to talk to DynamoDB. And in this case, we are just going to do a scan against the chat table. The table name is going to come in from our stack as the environment variable. Let's see, there you go. Close those two. And all we want to do is to return the chat name for every row, and that's it. And then for adding a new chat, this is what we're going to have. We're going to expect the post body to be a JSON, and it contains a chat name attribute. We're going to send a put command against the chat table with an object with just chat name, and chat name is our hash key for the table to ensure that it is unique in the table. We're going to enforce that uniqueness with this condition expression so that this put command will fail if a chat with the same name already exists in the table. And we're going to handle that conditional check failed exception and return a 409 instead of 500. Otherwise, we're going to just throw the error, and that's going to cause a 500 internal server error response. And we're going to use the course middleware to inject those course headers to our HTTP response. Before we deploy, let's add these two AWS SDK modules as dev dependencies, because once again, the AWS SDK clients are all going to be available in the Lambda's execution environment. So we only need these packages locally if we want to run the functions locally or to run some tests, and to also give us IntelliSense support while we are working in the IDE as well. Okay, so I think that's everything we need. Let's go ahead and deploy this stack. Once the deployment is finished, we can then capture the user pool ID, client ID, and API URL. And we're going to need those for the front end. So the front end can connect to Cognito and allow the user to sign in, create a user, and so on and so forth. And to be able to talk to our API endpoints to list the available chats, create a new chat, and to get a token so they can subscribe to Momento topics and to publish message to them as well. Okay, so the deployment is done and we have all the information we need here. So in the next lesson, let's look at the front end. Okay, I'll see you in a bit. As we did with the previous example, we have an AWS exports file, which helps us configure the amplify library as well as keep track of where our API endpoint is. And instead of hard coding our user pool ID and the user pool client ID and so on, we're going to load them from a .env file, which Vue.js is going to load by default. So we've added a .env file here. And we can go back to our stack output from the CDK deployment to capture the user pool client ID, the user pool ID, and finally the URL of our API. And I'm going to get rid of the trailing slash. And now that we have that, we can run npm run serve. And again, all the code for this demo project is available on GitHub, and the link is below. So this is going to run our front-end application on the localhost 8080. And if I go over there now, I can check if the configuration is correct by trying to create a new account using my theburningmonk.com email and set a new password. Okay, so the configuration is correct. Now it has sent me a new verification code by email. So I'm just going to grab that. 294742. Okay, so I'm able to sign in here. And right now there's no chat rooms in the database, so I can create a new one. Let's call this Momento. Create chat. And when I click on this, this is going to subscribe to a topic in Momento called Momento. And if we actually go back to the Momento console, we can actually look at this as well. So we can say US East 1, US East 1, and the cache I used is called chat. We can subscribe to a topic called the hash Momento, and this will be the same topic that our front end is connected to. So in the Momento console, I can subscribe. And so any messages that we publish here should also show up over here. And there you go. You can see from the front end, I've published a message to the topic with the sender email as well as the actual message itself. And from here, I can also send a message. And I can publish the message to the same topic. And since our front end is connected to it, so we're going to see it here as well. And of course, if I was to start a new incognito window, I can also go to localhost 8080 and create a new account. And we use my hey.com email in this case. And one more verification code, 171040. And so as we log in, it lists the chat rooms we have available. And when I click on that, it joins a new chat room and I can send a message. And this message will be published to the topic. And so anyone who is connected to that topic will receive that, including this client here, but also in here, in the Momento console. Okay, so let's look at what's going on inside the code itself to facilitate that. As before, we have the main.js module to create the view app, and the app.view is our entry point. And we're using Amplify's UI component to create the login screen. And once the user is authenticated, then we show a chat window component. And that chat window component is using a bit of a Tailwind CSS to compose the chat rooms as well as the chat window itself, and all the buttons and input boxes and so on. So again, you can go through the code yourself to look at this, but the actual CSS and HTML itself is not super interesting. So I want to just show you the code instead. While this component is initialized on mounted, we use the Amplify's auth module to get the current user and get the user's email and session. And then we will simultaneously call list chats against the chat endpoint. And this hits the list chats Lambda function behind the scenes. And because this is an authenticated endpoint, so we have to pass along the JOT token in the authorization header. And if you remember from the backend, the list chats API, the list chats function, this returns an array of chat names. And so we are using that, and we're extracting the chat names into an array, which is then used to show the list of chat rooms here. And when we click on any one of these, it calls the join chat function with the chat name, which is prefixed with the hash. And this is where we're going to check if we have an active subscription to another topic. And if we do, we're going to unsubscribe first, and then we're going to subscribe to another topic. And this is pretty much exactly the same helper function that we saw in the last demo application, where we take an auth token, which is the disposable token that we get back from the token endpoint. And if we need a quick reminder, in the response from the token vending machine, we're going to return back the endpoint, which we don't really need because the Momento SDK knows where to find the cache. But we have the token, the cache name, and when the token is going to expire. So we're going to make use of the token to initialize the instance of the topic client from the Momento SDK for web clients. And once that's initialized, we're going to call subscribe with the cache name and the topic name, which in this case is not going to be our user ID because we want to subscribe to whichever chat that you have just clicked on in the front end. So in this case, the topic name is going to be hash Momento. And we're going to pass along a delegate to be run against the item that we got back from the Momento topic. And in this case, we're going to say, when we get a new message, we're going to extract it because we know it's going to come in the form of a JSON structure like that. So we're going to extract the sender and the message so we can push them to an array, which is what we use to display in the UI component here. And going back to the unmounted handler, we're also going to initialize the Momento as well. This is where we're going to call the token endpoint and extract the Momento token from the response, as well as the cache name, the two pieces of information that we need to connect to the Momento topics. Ideally, we also want to make use of the acceleration time so that we know when our token would have gone stale and we need to fetch a new one proactively. And to create a new chat, we hook up a function to this create chat button, which will make a post request to the chat endpoint, which will trigger the new chat Lambda function to then add a new item in the chat table. Just for consistency, we are prefixing the chat name with a hash. And again, it's an authenticated endpoint, so we have to pass along our JOT token from the current authenticated session from Cognito. And lastly, to send a message to the chat room, we have a send message function, which uses the current subscription object we have to send a message. And this object is what we return from the subscribe to topic helper function from the Momento module. This is so that we have a closure that allows us to say unsubscribe from the current topic, and also have a way to say send a message to the current topic without exposing the topic client and the subscribe response back to the UI component, which would be a bit of a leaky abstraction. So instead of doing that, I'm returning essentially a subscription object which gives you access to the two operations that you're going to want to perform against the topic to send a message and to unsubscribe. And so when we send a message, we're going to send to the same cache, the same topic, and just take whatever message that you want to send. And in this case, it's going to be a JSON structure, as we saw earlier in the Momento console, that includes a sender and a message. So that's it, a very simple front-end application that allows you to have a real-time chat between different clients by subscribing to and publishing a message to Momento topics. And as we saw earlier, we can also use the Momento console to see all the messages that has been published to the topic as well. And that wraps up the third and the final demo application in this course. Please feel free to play around with the code in the GitHub and take it even further. And if you build something interesting from it, please let me know and show me what you've done. Alright, congrats on finishing this course. I hope you have found it useful. And as a quick refresher, here's what you should have learned. So number one, you should have learned how to use Momento Cache, which is pretty straightforward. You basically install the Momento SDK, initialize a cache client, and use it to talk to your cache. And that's about it. But you need to create API keys. And we talk about how to securely handle these API keys and why I would avoid putting them in environment variables in plain text, and why I prefer to load them at the runtime instead and use something like MIDI's SSM middleware. We also saw how you can use Momento topics to subscribe to and publish real-time messages. And again, you just create an instance of the topic client from the Momento SDK, and you can do this from your backend or from your front end. But you don't want to hard code your API keys in the front end, and instead you should have your backend generate those disposable tokens for the front end to use. And you can do this with the auth client, which requires you to set up Momento super user keys. So you can use the generate disposable token method to create a temporary token for the front end. And then you can also lock down on what actions the front end can perform against which resources. And in the case of topics, we can say the token only allows the front end to subscribe to a topic and not publish to it. And we saw an example of how you can use this to allow the users to subscribe to their updates, but not anybody else's, by using user IDs as the topic name. And we saw how we can use Momento topics to build real-time applications. For example, to build a real-time notification system from the backend to the front end. And we saw how to implement the client-to-client communication, such as a real-time chat application. If you want to learn more about Momento, then head over to gomomento.com and maybe sign up for an account and start using it. They have a generous free tier, and they are also working on a durable object storage solution as well, which will be integrated with their caching solution as right behind cache. So I'm actually looking forward to it. Oh, and they also have a pretty good blog section as well, with lots of tutorials on how to use Momento in real-world applications. Finally, if you want to reach out to me and learn more about building serverless applications in the real world, then here are my socials. And once again, thank you for taking this course, and I hope to see you some other time. Okay, bye for now. Hi, I hope you have enjoyed this video. And if you do, why not check out these other videos and learn more about serverless development.